Hi, I'm putting together these short videos to kind of review the the way we go about solving the problems that we looked at back in chapter 2. And this first one is on section 3. There are 3 parts to that section. All have to do with solving different types of absolute value equations. And you can see the 3 different forms that we're looking at are very similar. We have the absolute value of ax plus b is equal to c. We have the absolute value of ax plus b plus some number c is equal to d. And we have 2 absolute value expressions that are equal to each other. Ax plus b, absolute value, is equal to absolute value of cx plus d. And we're going to see how we go about solving these, and then I want you to practice some of those on your own. Okay, so we'll begin with the first 2 types of examples. In the first example, we have absolute value of 2x plus 5 is equal to 11. If you recall, we said that absolute value is a distance. It's the distance of a number away from 0 on the number line. And if we're looking for a number that's 11 units away from 0 on a number line, then we know that that number could either be positive 11 or negative 11, because both of those are 11 units away from 0 on the number line. And what we're told is that the quantity 2x plus 5 is 11 units away from 0 on the number line. And so we end up with 2 equations from this, that 2x plus 5 is equal to negative 11 or 2x plus 5 is equal to positive 11. And we get these 2 different equations, which we then just solve in a regular fashion, solving the equations 2x plus 5 equals 11, 2x plus 5 equals negative 11. With the first equation, we're going to subtract 5 from both sides. We end up with 2x equals 6. We then divide both sides by 2, and we get x is equal to 3. So that's one of the values for x. And if you notice, when we go back to the original expression, 2x plus 5, when we substitute 3 for x, we get 2 times 3, which is 6, plus 5, which is 11. And so that expression is now 11 units away from 0 on the number line. 3 is the value of x that makes the expression 2x plus 5 equal a number that is 11 units away from 0 on the number line. In the second equation, again, we subtract 5 from both sides. We end up with 2x equals negative 16. We divide both sides by 2. We then get x is equal to negative 8. And when we substitute negative 8 into the expression 2x plus 5, we see that that equals 2 times negative 8, which is negative 16, plus 5, which is negative 11, also gives us a number that is 11 units away from 0 on the number line. Right? So there are 2 solutions to this problem, and that is in the expression absolute value of 2x plus 5 equals 11, there are 2 values of x that make that statement true. X equals 3 and x equals negative 8. We call those the solutions to this equation. Those are the values of x that make it a true statement. That's what we mean by solving the problem. Okay, in the next example, it's going to be very similar. We don't need to go through the whole thing all over again, but this expression 1/2 x minus 1 has to be a number that is 5 units away from 0 on the number line. So it could either equal 5 or negative 5. And so there are 2 equations that come from this. 1/2 x minus 1 is 5. 1/2 x minus 1 is negative 5. We're going to add 1 to both sides, and we can do that in both equations at the same time. Add 1 to both sides, we get, on the left-hand equation, 1/2 x equals 6. On the right equation, 1/2 x equals negative 4. Now the easiest way to proceed with this is to multiply both sides by the least common multiple of all the denominators, which happens to be 2. So I'm going to multiply both sides of each equation by 2 and distribute that multiple of 2 to both sides of each equation. On the left, I get 2 over 2x equals 12, which means x equals 12. And on the right, 2 over 2x equals negative 8, which means x equals negative 8.